Welcome back to another exciting project, and I'm happy to have you joining in for another fun and educational build. In this project, we're going to create the classic rock, paper, scissors game, where you'll compete against the computer in real time. As you can see from the final version of the project, we have three options to choose from: rock, paper, and scissors, all displayed clearly on the screen. For example, if we click on the rock symbol, we'll immediately see the result displayed, and in this case, it happens to be a tie between us and the computer. As you can see, when the result is a tie, the scores remain the same. For both the player and the computer, it stays at 0. At this point, our score is 0 and the computer's score is also 0, which means no one has taken the lead yet. If we make another choice, we might still end up with another tie depending on what the computer randomly picks. Now, in this round, we lost the game. As you can see, rock beats scissors because the computer's choice was rock and our choice was scissors, giving the computer a score of 1. If we continue playing the game, this time we manage to win, since rock beats scissors and our score increases accordingly. That's because our chosen symbol was rock, and the computer happened to select scissors, resulting in a clear win for us. We're going to start by creating this project using HTML to build the structure, then move on to CSS to add a clean, modern design, and finally use JavaScript to generate random computer choices and compare them with ours dynamically. We'll also display the game's results in text form and track the players' and computer scores at the bottom of the screen so you can see your progress as you play. So, in the next section, we're going to begin by writing the HTML structure that will serve as the foundation for our rock, paper, scissors game. See you in the next section, where we'll start building our project step by step. Welcome back to our rock, paper, scissors project. In this section, we will build the project's HTML structure. For reference, I have placed the final version of the project here on the screen. Looking at our finished version, you can see we have a title, 3 emoji options for rock, paper, and scissors, and the score display. Let's start by creating our main heading. Next up, we have a paragraph and a containing div for our 3 buttons. At the bottom of our layout, we have the score display. The very first step is to create our HTML file. I will create this project on my desktop. I will now navigate to my desktop to create a new folder. I will name this folder Rock, Paper, Scissors after our project. Once we have created the folder, you can simply right-click on it and select Open with Code to launch Visual Studio Code. I personally use Visual Studio Code as my favorite text editor, but you can absolutely use any editor you're comfortable with. Now that Visual Studio Code is open with our project folder ready, we can create a new file and name it index.html. Now that we have our empty file ready, we can quickly generate an HTML boilerplate by simply typing an exclamation mark. To quickly generate the HTML boilerplate, simply type an exclamation mark and select the first auto-suggestion that appears. Let me explain this boilerplate code quickly. If this is your first time working with HTML, the doc type declaration tells the browser which version of HTML we are using. Since we're using HTML5, having just the word HTML here is enough to tell the browser we're working with the latest version. Next, we have the HTML tag itself, which wraps around both the head and body sections. The language attribute specifies which language our page uses, and we're setting it to English with the value EN. Our first metadata tag defines the character set, and UTF-8 is recommended by HTML5 as it includes nearly every possible character and symbol. For instance, if a user visits the website and wants to see these specific symbols or fonts, they will be displayed correctly because UTF-8 covers nearly all common characters. Next up is the compatibility meta tag that ensures Internet Explorer uses its most modern rendering engine, Microsoft Edge. Next up is the viewport meta tag, which makes sure your website's width perfectly matches the screen of whatever device someone is using. For instance, a person viewing the website on a mobile phone will have a much smaller screen than someone using a tablet or desktop. The initial scale property sets the initial zoom level to 100%. Finally, we have our title tag, which currently displays as Documents in the Browser tab. To view our project in the browser, we will use a very helpful extension called Live Server. If you already have this installed, you can skip ahead. Otherwise, open your extensions panel with Ctrl+Shift+X and search for Live Server to find and install it. If you have not installed it yet, you can install this extension, which will create a local server for you. Once you have the Live Server extension installed, you can launch it by clicking the Go Live button, or by right-clicking your file and selecting Open with Live Server, which will automatically open your site in the browser and refresh it every time you save your work, provided you have autosave enabled in Visual Studio Code. You can see the document title is currently displayed in the browser. Let's update the title to match our project name, Rock Paper Scissors Game. If we check the browser now, you will notice the title has updated to Rock Paper Scissors Game. Let's arrange our windows by placing the website preview on the right and Visual Studio Code on the left. Now let's add our main heading tag with the project name so you can see it appear on the website as Rock Paper Scissors Game. Now you can see our title is appearing on the page. Next, we will add a paragraph that prompts the user to choose their move. Next, we will create our 3 selection buttons. I am going to add the 3 buttons now. Here we have our 3 buttons for rock, paper, and scissors. Now, I want these buttons to appear side by side rather than stacked vertically. To align these buttons horizontally, I will place them inside a container and assign it a class called buttons. Now, you can simply type .buttons and press enter to create our first button container, and you might notice I'm getting a code suggestion from GitHub Copilot here. Just to let you know, GitHub Copilot does require a paid subscription. The good news for students is that you can get GitHub Copilot for free, and it will suggest code based on your previous work and common online patterns. This AI pair programmer uses GPT technology to provide real-time suggestions directly within your Visual Studio Code editor. Of course, using GitHub Copilot is completely optional for you. Feel free to type the code manually yourself. I am going to accept this suggestion for the 3 buttons. Let's assign an ID to each of these buttons. Instead of just using the word rock for the text, I want to use something called HTML entities. HTML entities are special codes that let you display symbols on your website. For the rock symbol, you would write this code. Let me zoom in so you can see the rock symbol emoji clearly, and for the paper emoji, we use this symbol. You need to add a semicolon at the end. For the scissors emoji, we use this HTML entity code. And with that simple method of using HTML entities, we now have our 3 emojis displayed. If you are not sure which symbol to use, you can always search online for HTML entities related to rock hand, paper hand, or similar terms. You can easily find websites online that display these symbols for you to copy and paste. Now that our buttons are in place, we will add a paragraph to display the game results. Next, I will create a paragraph with an ID of result and temporarily hard code the word U1 into it, followed by another paragraph with an ID of scores. Inside this paragraph, we will display your score. Let's create a paragraph for your score and assign it an ID. For example, we could call this player score or user score. Next, we will add the computer score by creating a span element with the ID of computer score. We will use these IDs later in our JavaScript to update the scores. For this stage, we are using these hard-coded values because we will focus on styling our elements with CSS in the next section. As you can see, we have now built the complete structure with our title, the Choose Your Move prompt, 3 selection buttons, and a score display for both you and the computer. That completes our HTML structure for the project. In our next section, we will use CSS to transform our project into a modern design. So see you in the next section. In our previous section, we successfully built the HTML structure. In this section, we will style our project with CSS to match the final version, adding a background color and custom colors for the emoji buttons. Our main goal is to center everything on the page, and the first step is to create a CSS file. Let's open our File Explorer and create a new file named style.css, then we will link it to our HTML file. Let's close that File Explorer panel for now. This link needs to go inside the head tag. To add the link, simply type link and select the third auto-suggestion for the CSS option, then set the href to style.css since both files are in the same directory. The href attribute should point to our style.css file, which defines the styling relationship. With that link in place, we can now use our CSS file to style the project. The first element we are going to style is the body section. In our HTML structure, the body element wraps around our entire project. First, we will target the body tag by simply typing body. Let's start by changing the background color. For the background color, I'm going with a light gray that uses the hex code F1, F1, F1. That's the light gray background color we're using. Next, we will set the font family for our text. Let's change the font for all our text using the font family property. For the font family, I want to use Arial. We should add a semicolon to complete this code. Let's add that semicolon we missed. For the font family, we are using Arial as our primary choice, with sans serif as the backup option. We also want to remove any default margin and padding from the page. This step will remove the default margin and padding. That completes the styling for the body section. Next up, we are going to style the main heading, the h1 tag. Let's move on to styling the main heading. For the heading, let's set a font size of 2 rem. The value 2 rem means we are doubling the default font size, which is typically 16 pixels. Let me adjust the zoom level so you can see the changes properly, then we'll center the heading with text align and add a top padding of 100 pixels. This padding will push our heading down a bit, and next we will style this paragraph. Now let's look at the first paragraph, which says, "Choose your moves." We should also style the other paragraphs. Next, I'll select the paragraph tag and adjust the font size. We can see the suggestion that appears is acceptable. Next, we will set the font size to 1.2 rem. Next, we will center this text using text align center and then add a bottom margin of about 0.5 rem, which equals 8 pixels, to create some separation between the elements. Let's move forward by styling these buttons next. Let's start by targeting the div that has the class of buttons. Next, we will center all of the items. Next, we are going to target the div with the buttons class. To target this class, we simply write .buttons since the dot indicates we are selecting a class. To center the buttons horizontally, we will set the display property to flex and then use justify content center. We can remove this margin property here. Using justify content center aligns all our items horizontally in the center of the container. The key point here is that you must set the display to flex in order to use justify content center. Now let's focus on styling the individual buttons themselves. Now we need to target each individual button element. Let's remove the border from these buttons entirely. We will set the border property to none. Let's change the color for these buttons. Actually, let's skip changing the color for now. Let's set the font size to 3 rem to make these buttons much larger. This will make the emoji buttons much larger. Next, we should add some margin around these buttons. We will add a margin with 0 for top and bottom and 0.5 rem for left and right, which creates space between the buttons, and we also add padding of 0.5 rem. Right now, the padding is invisible, but it will become clearly visible once we add a background color. To make the interaction more intuitive, we can change the cursor to a pointer when hovering over these buttons. This gives us a pointing hand cursor on hover. Let's add a background color now so the changes become more visible. Let's add a temporary background color to these buttons so you can see the changes clearly. Next, we will make the corners rounded by setting the border radius to 5 pixels, and then we can create a hover effect for these buttons by using the hover pseudo class. For the hover effect, we can change the opacity to 80 or 70%. You can observe that when you hover over a button, its color becomes slightly lighter, creating a nice hover effect, although the change happens very quickly. Let's add some transitions so the effect looks much smoother. To create a smoother hover effect, I'll add a transition that lasts for 0.3 seconds with an ease in and ease out timing function. You can see the transition effect in action as you hover over the buttons. Now we are going to remove this single background color. Now I want to assign a different background color to each of these buttons. Next, let's target the rock button specifically and change its background color to red, which looks good, and then we will move on to style the paper button. Let's use blue for the paper button, which has the hex code 296F3, and then we'll give the scissors button a green color. As you can see, GitHub Copilot is providing code suggestions for us. Initially, I planned to avoid teaching with GitHub Copilot, but with AI advancing so rapidly, I believe it's essential to learn how to use these tools for faster coding. While AI assistants like GitHub Copilot can speed up your coding, it's crucial to understand the underlying code. For instance, let's understand what this code does and why we use the pound sign. For instance, we previously assigned an ID called rocks. We use the pound sign, also known as the hashtag, to specifically target the rock element. Understanding these concepts is important, but you can use this assistance to code more quickly as we now style the player scores for both user and computer. Let's set the user score color to green and make the computer score red. To target the user score, we use the pound sign followed by user score. Let's take a look at the color suggestions we get. The user score is now blue and the computer score is red. The colors look good for our scores. That completes all the styling for our final project version. Now we are ready to bring this project to life with JavaScript. You can see we are now able to select the different emoji options. For example, when we click the rock button, we can see our score being recorded right here. As you can see, your score and the computer score are displayed separately here. In our next section, we will dive into the JavaScript portion of the project. Our design is looking quite good at this stage. In our next section, we will bring the game to life using JavaScript by adding event listeners to the buttons and writing logic to calculate the winner, including creating a random computer move. We will compare that user decision with the computer's decision. We will then compare the user's decision with the computer's decision to determine the winner and update the score display. Stay tuned for the JavaScript part coming up next. Perfect. We just wrapped up the CSS portion of our project. Now, let's get into the JavaScript to make our game interactive. Our first step is creating a JavaScript file in our project folder. To get started, let's open the File Explorer by pressing Ctrl, Shift, and E. I'm going to create a new file called index.js, but feel free to name yours something like script.js instead. Just like we did with our CSS file, we need to link our new JavaScript file to the HTML document. However, instead of placing our script in the head section, we need to put it right at the end of the body to ensure the file loads properly before we call its functions. If we don't do this, the JavaScript code won't be able to interact with our page elements. Our script tag is ready with the file name index.js in my case, and since both files are in the same directory, the source path is simple. All we need to do is type index.js into the src attribute. With our JavaScript file properly linked, we can now use the index.js file within our project. The very first step we need to take is to access these buttons. To proceed with our JavaScript functionality, we need to gain access to these buttons. Now these buttons all use the HTML button tag element. To target these buttons, we can use a method called querySelectorAll. Let's create a constant called buttons that targets all the button elements on the page using the querySelectorAll method. Perfect. We now have full access to all of our buttons. The next step is to add an event listener to each button. When we click on a button, we can trigger a specific function to run. Next, we use the forEach method on our buttons to individually target each one, as you can see from the code suggestion, and then we attach an event listener to every single button. The event listener we are going to implement is for the click event. When we click on the button, it will trigger a function. For example, we can start by logging a simple message like, "You clicked me," to the console. I also want to display exactly which button was clicked. Since each button has its own unique ID like rock, we can easily target the specific one that was clicked. We can simply log the button's ID here. However, I think this should be placed outside of this current function. Let me check what's happening with the console output. Let's open up the browser console by pressing the F12 key. Let's bring up the console panel at the bottom of the screen. Let me just move the console panel up a bit. Let's clear the console first to start fresh. Let's refresh our page and then click on the rock symbol. When I click on the rock button, the word rock should appear in the console. As we can see from the console, we are encountering an error. Let's take a closer look at this error because I think we might have missed a closing parenthesis somewhere in our code. That's the issue, we're missing a closing parenthesis right there. Perfect. Now when I click on the rock button, the console shows, "You clicked me rock." If I click on the paper or scissors hand sign, we get the same console message for each. Now that we can access the button IDs, we should create a function to compare our choice with the computer selection. The first thing we want to do is create a function that will handle the computer's play. You can see the Copilot is already providing suggestions. For the computer's move, we will create an array of choices containing rock, paper, and scissors. For this, we are going to use a random selection. We use the random method to generate a decimal number between 0 and 1, and we multiply that result by the length of our choices array. Just to clarify, arrays are zero-indexed in JavaScript, meaning the first item is at position 0, the second at position 1, and so on. This method will generate a random number between 0 and 2, which we can then use to select a choice from our array. For example, if the random number we calculated is 1, then we would get paper. If the number is 2, we get scissors, and if it's 0, we get rock. This method will return our random choice, and we use math.floor because the random number can be a decimal like 0.1 or 0.2, and we want to round it down to the nearest whole number. Now we have everything we need to calculate both the player's choice and the computer's choice. Now let's get this computer choice stored in a variable. Let's start by logging our choice to the console. Let's store our selection as the user choice and also log the computer's random choice to the console before we proceed to call this function. Let's refresh the page and test our progress by clicking the rock button. Now when I click on the rock button, we can see my choice is rock and the computer randomly selected paper. This means we now have a random computer selection every time we click a button. For example, if I choose scissors as my selection, you can see my user choice is scissors while the computer randomly selected rock. Now that our system is working, we need to compare these choices to determine the winner of each round. Now let's take this a step further and create another function to handle the game logic. Next, we will create a function called playRound, which will take in two different inputs. This function will receive two arguments, our selected choice and the computer's generated choice. Now let's format the function name using camel case. Let's go ahead and create that function now. I'm going to create this function called playRound, which will take both the player selection and the computer selection as parameters. I'm going to accept this suggestion from Copilot using the tab key. I'll simply press the tab key to accept that Copilot suggestion. For example, if both the player and the computer choose rock, the function will return that it is a tie. Now, if you choose rock and the computer picks scissors, or you choose paper and the computer picks rock, or you choose scissors and the computer picks paper, the function will return a "you win" message. This will display which option you selected, like rock for instance. For example, we can return a message saying rock beats scissors. For all other cases, the game will return a "you lose" message, showing that the computer's selection beats the player's choice. Let's run the code and see what results we get. Now we are calling the playRound function. Perfect, we are now receiving both inputs we need. We pass the button's ID that we clicked along with the computer's randomly generated choice. We pass both choices into this function to determine the winner, and then we return the result as text. This function will tell us if you won, lost, or if it's a tie. Let's go ahead and log that result to the console. Let's take the result we get from this function and log it to the console. Let's store the result in a variable and then log it to the console. Let's check the console to see what happens. Let me click on the rock button, and we are getting an error that log is not defined. Let's refresh the page and see if that resolves the issue. Let me click on paper, and I lost because paper beats rock, but the computer had rock while I had paper. Let me choose the paper button this time, and I lost because the computer chose rock, which beats paper. In this case, I chose rock while the computer selected paper, which is why I lost that round. Let me try clicking on scissors this time to see if I can win. It looks like we have a tie again for the second time. It seems like the computer has the upper hand right now. Let me try to win one this time. In this case, I chose scissors, and scissors beat paper. The computer randomly selected paper for its choice. Now we are successfully retrieving the game result and displaying it in the console log. However, I would prefer not to just log the result to the console. Instead of just logging to the console, I want to update this hard-coded result text here with our dynamic results section. Now that we have our playRound function working, we need to process its results. We return the result from this function here. Now that we have the result from our function call, let's display it on the page instead of just logging it to the console. Now I want to target that paragraph element with the ID of result and update its content. Next, I need to grab that paragraph element. Now I'm going to create a constant called result element that we can target using query selector and point it to our result element. Another option is to use the getElementById method and simply pass in the ID result. Perfect. Now we have access to the result element we need to update. Next, we can update the displayed result by setting the text content of our result element to the outcome we calculated. Setting the text content will update what is displayed inside that element. Let me demonstrate by choosing the rock option, which results in a loss since the computer selected paper and paper beats rock. Let me choose a different button, and this time it's a tie. Now I've made another selection and lost again. This confirms our functionality is working correctly. The problem is that we are not currently keeping track of the score. Right now, both the user and computer scores are starting at 0. The next step involves keeping track of the score. At this point, we are returning the game result text, but we still haven't implemented the actual score tracking for the player. Now I'll create two variables using let to track the scores, one for the player and one for the computer, which will update whenever either side wins a game. For instance, when we return a tie result, the score value should remain unchanged. In the case of a tie, the scores will remain unchanged, but if we win, we will increase the player's score by 1. The ++ operator increases the value by 1. For example, if the current score is 1, it will increment to 2. This means the score will increase from 2 to 3. The ++ operator increments the variable by 1, and if we lose the round, we will increase the computer score. Now that we are updating the scores in our code, we also need to update the numbers displayed on the screen. To update these scores on the screen, we need to grab those elements. We need to grab those two score elements next. Now I'll also grab these two score elements to update them. Next, I will create a constant variable. Next, we need to create a constant for the player score element, which has the ID of player score. Looking at the ID in our HTML, this element is actually called user scores. Let's update the variable name to userScore for consistency, and we can use the same getElementById method to target the computer score element. With these elements now stored in variables, with these elements selected, we can now update the displayed scores. Now that we are updating the scores, we can also change the displayed values here. Now we will update the player score by setting its text content, and then we do the same for the computer score. Let's test this out and see what happens. We update the text content to display the current computer score. Let's test this out now. As you can see, I lost that round, which means the computer score increases by 1. Notice how the computer score has increased to 1. Let me zoom in on this for better visibility. Let me click on scissors this time, and I win because scissors beats paper. If we get a tie, the scores remain unchanged. As you can see, the scores are updating with every click, allowing you to keep track of your progress throughout the game. If you want to start a completely new game, you can simply refresh the page to reset the scores back to 0. Let's go ahead and remove that hard-coded text from our result area. Let me remove this hard-coded text so the results area will be empty until we click a button and see the score changes appear. That concludes the creation of our project using JavaScript alongside HTML and CSS. In this section, you have learned how to access elements using methods like querySelectorAll for all buttons and getElementById for targeting specific IDs. We also set up two variables to track the player and computer scores. Next, we added an event listener to each button using the addEventListener method, which then calls our playRound function with both our selection and the computer's randomly generated choice. We created the playRound function to receive both our choice and the computer's choice, compare them, and then return a result of tie, lose, or win. We then updated both the player and computer scores by changing their text content. That concludes our work on the JavaScript functionality. I hope you found this tutorial both enjoyable and informative. I'd love to hear your thoughts on using GitHub Copilot to speed up project creation. Using GitHub Copilot has also helped me save time while teaching these projects. I'd love to hear your thoughts on whether I should continue using Copilot to speed things up, or if you'd prefer me to type everything from scratch instead. I look forward to seeing you in the next project.